Hello and welcome to AVR TV. For portable electronics, an ongoing challenge has always been battery powering. A typical microcontroller requires at least 1.8 volts to operate, but the voltage of a single battery cell typically ranges from 1.2 volts to 1.5 volts when fully charged, and it then gradually drops well below 1 volt during use, while still holding a reasonable amount of charge. So, if you want a micro in there, that means at least 2 battery cells are required. If it's a small application, this could practically double the size and weight of it, or at least complicate several aspects of the design, including the aesthetics. And this may not be something that you want. If your application uses non-rechargeable batteries, excess current consumption during runtime, like when switching in a motor, can make the combined battery voltage drop to a level where the micro shuts down. Also, in a similar situation with rechargeable batteries, battery supervisor circuitry may consider the battery discharged to the safety limits and switch it off to avoid battery damage. In both these cases, you may not get to utilize all of the charge stored in your batteries. Now, these are obvious inconveniences, so what can we do about them? A boost converter is a device that converts a DC voltage to a higher level. It is a class of switching mode power supply that typically doesn't require many components. So how about integrating this into a microcontroller? And this is exactly what we have done with the new ATtiny43U device. The boost converter inside this device provides a fixed supply of 3.0 volts from a single cell battery. Even when the battery voltage drops down to 0.6 volts, the voltage on the micro will stay 3.0 volts, also through periods of excess current consumption. This allows non-rechargeable batteries to be drained to the minimum, thus extending the battery life. For rechargeable batteries, there are programmable shutoff levels above their critical minimum voltage levels. And this way, any battery type can be fully utilized: alkaline and silver oxide, lithium-ion, zinc-air, nickel metal hydrides and nickel cadmium, and so on. In addition, the ATtiny43U can deliver up to 60 milliamps at 3 volts. So you can drive an LED or a motor directly from the I/O pins. Now, the converter only needs an external inductor, a diode and some bypass capacitors, and is completely self-sufficient and independent. It does not need any control from the microcontroller. The converter just starts automatically as soon as there is sufficient voltage at the input from the battery. With 4 kilobytes of flash and a 20-pin package, the ATtiny43U will find its home in small handheld applications like digital cameras and accessories, MP3 players, GPSs and PDAs, little motor applications like personal care equipment, remote controls, portable medical equipment and solar-powered equipment. Development tools are in place, of course. You just use the ordinary range of AVR tools. AVR Studio has a built-in support for this device from version 4.15. In addition, we provide a ATtiny43U plug-in board for the SDK600. This board has an op-amp-based battery emulator and all the required passive components, so you can start firmware development and PCB design in parallel right away. The ATtiny43U bridges the gap between the minimum supply voltages of modern microcontrollers and the typical voltages of standard battery cells, allowing you to design lighter, smaller applications that utilize the energy potential of any battery more than any other device in its class. Add the renowned performance and ease of use of the AVR, energy-saving pico-power technology and reliable development tools, and you have a winner. For more information about the ATtiny43U, please visit our website. That's all for now. Stay tuned for more good tech news from Atmel. Bye bye.